Okay, now we put some soldering in. We need to find pin 1. Pin 1 is in there. Okay, so we mounted the first corner, and now we'll go on the other one, on the other corner. My eyes. Okay. Okay. So this device is fixed on 2 points, on there and on there. And now the idea is just to put a lot of flux on, but let's have first a look. Yeah, I think. Yeah, I think I managed. I hope that this flux is still okay. Yeah, flux is not so good. Somehow, maybe it's old, huh? Is it possible? Is this possible? Okay. Is this possible? That we managed it, maybe, huh? So, the PC board is assembled and it's now running as it should actually be. But I made a few mistakes I want to share with you. Big mistakes actually. The first one is that I have mixed up the input and the output line of the programmable data interface, and as these wires are also wired to here and to other places, I exchange these at the connector itself. So I did not change the connector, I have cut lines and then I made 2 cross cables here. And there I did this. The other error was that I messed up with, actually I messed up a lot, that I messed up with the ground connection. I connected it firstly, with the reset connection, I connected it first to the output of the voltage monitor, but it could not drive it completely to 0 volts, the programmer, because the voltage monitoring was working against to it. I will show you in a minute on a circuit. So I disconnected the reset line from the output to the master reset input, and this makes actually sense, right? This was the second mistake, and the last mistake was that I used a resistor array network because I was so unsure while designing this PC board that I looked at the internet and I found a circuit of a development board, and they use such an arrangement, and I was thinking, let's do this, it will be cool. But now I come again to my conclusion that we should use always our own brain. And so I will show you the errors in the circuit diagram, and then I will demonstrate this thing to you. So this resistor network on here and this one, to the signals master out, slave in, and master in, slave out. They are causing that the VCC line on here at 2.2 is the VCC line, that there is always a kind of offset existing. So what I did, I removed these resistors. I will now update the circuitry, this one here, this one out, this one out. And these resistors, partially I let them in, and one I removed and made a short, a direct connection. So, like this. So it's now correct on here, and these connections also I don't need. So this is with the resistor network thing. And okay, so this one here is not the reset line. It should be named actually reset somehow programmer, right? Reset programmer on here, and I will remove this label on here. So this one, and this one is connected not to there. It should be connected to there, to the master reset input, and this is the reset line for the circuitry. Okay, so this is the second error I made, and I corrected on here now with this one here. Okay, and then the last one is that I mixed up. I don't know how I managed it, but okay, this one I corrected already, right? Master in, slave out. Yes, this is on here. You see program data output of the ATMega, and if the ATMega as a slave is outputting, it's the input for the master in, slave out. So I have these two have been inverted, connected to here, and this was the third error I made. So I was lucky actually that I used, and actually not just for this reason, right? But I was lucky that I use a two-layer board, and that I am so hesitating to use ground planes. It would not be so easy. So, you know, don't understand me wrong. I'm not against ground planes. I'm against something to use because others are doing. Yeah. So like I did a mistake with the resistor network, right? We need to think with our own brain. So I put two scope probes, one on here and one on the reset line. Maybe you will see. And a third one I will put also beside this one here, so we can see, I hope, the programming data lines I/O and the reset signal. And I need also to turn on the last one. So on here the violet one is a reset. There's a ground potential, so it already shows us a high level on, and we'll set the trigger to the falling edge. For the falling edge on here somewhere. We are now at 10 microseconds, but we will make it very, very slow, because it's very slow, this communication somehow. Yeah. So let's try to touch this without the other probes are falling away apart. And I will click on the software again to read out the component. So let's make a single one, and now start this program. I know. To my 50, 100, 200 milliseconds. Let's make like 500 milliseconds even, okay? So Okay, so something worked. Okay, you see it stopped on here. Let's make the amplitude of channel a little bit smaller. Now they are all equal, and we see on there how the reset is pulled low by the programmer and kept low, and after it finished it goes up. And in between of this one on here, so it seems that they are on here are somehow like this. Okay, so we see that the yellow line is asking the IC something, and the IC is responding, and it tries to figure out specific frequencies somehow. Yeah, it gives like a start signal. Oh Jesus Christ. Okay, here, yeah, it gives a start signal, nothing, then another one with other settings, and then it's starting to respond. And this is what happens on here. And it's a little bit difficult, right? It's a little bit difficult. Oh, now I lost it. Okay, anyway, but we have seen it. Okay, it's so slow, the signal. You remember I put to 500 milliseconds. It's a half second, man. Ah, there it is again. It's a storage oscilloscope. Yeah. So, you know, and within this, let's say 0 bits. Okay, the resolution is not anymore, you know, because of this 500. Okay, anyway, but such like the communication looks like. Okay, so see you. I don't know when. I need to learn, you know. I need to learn to program in C, the ATMega. So let's see. Have a good evening. Bye. And I'm so happy that it worked out. Actually, I needed to unsolder the first ATMega I put on. I removed it because I was thinking that this is broken. And somewhere on here, you see on there, these are the resistors. So this I sacrificed somehow. Okay. Anyway, bye.